Okay, here we go. And we're off. So today is going to be a very important video because it's about the origin of the universe, the beginning of the universe, and how everything happened. Now, most of what we hear in cosmology is not actually science. A lot of the principles and math, some of it's okay, but the main emphasis, the main thrust of all cosmology and all this stuff is not even science. The Big Bang is not science. The multiverse is not science. The expansion of the universe is not verified. It's not science. Not from a little single point. That's not verified. That's not science. Invisible matter is not science. Invisible energy, that's not science. Aliens, or what they call panspermia, seeding life on Earth, that's not science. Multiverse, is appeal to infinite possibilities. Panspermia is an appeal to life coming from somewhere else because it can't possibly form here, but it's not forming anywhere else either. So all this, the main thrust of all cosmology and all what they call science, is not even science. So I'm going to propose an idea that is based on science, that is based on observation, and that is dealing with the time, light, distance issue. So let's go ahead and go right to the paper, since we have an assistant called Grok who's helping me write papers, because I can think through it through my head. In my head, I can think through stuff, but I can't really do all the math or anything. So, but I know the math can be done because I've never studied math a whole lot. So this highlighted part here is in the description. We'll go ahead and go through the whole thing, the whole paper. It's not a very long paper. Okay, space-time without mass, refuting the standard model assumptions. Because, again, all of so-called cosmology and things people say is not even science. There are assertions, assumptions, conjecture, speculation, imagination. It's not science. So this anonymous here, this is jungle jargon. We got an abstract here. Standard cosmological model relies on unverified assumptions, such as uniform flat spacetime. This is what they call the Minkowski flat spacetime. It's an assumption. Nobody went out there and measured how much gravity affects time and distance. It's an assumption. And it's not science. And it's a significant part of general relativity, which general relativity is observed, but flat space-time is not observed. Okay, the universe, flat space-time, and constant light travel metrics. So that if you have a flat space-time, you're assuming a constant light travel metric, lacking empirical basis in regions with varying gravity. We propose that space-time is defined by matter. Now, if you can tell me something else that affects time and distance, well, you could say electromagnetism and energy, which all basically is from matter. So we propose that space-time is defined by matter, mass, and gravity. That's the only thing that affects space-time. Without mass and gravity, there's nothing to slow down time or shorten distance. In interstellar and galactic voids, where mass is negligible, time accelerates and distances expand, enabling light from Sagittarius A and the distant galaxies to reach Earth in under 6,000 to 7,000 years of proper time, that's our time, while maintaining maintaining the speed of light. This suggests overestimated distances, 26,000 light years to Sagittarius A, and a universe age far below the standard 13.8 billion years. Because between here and a distant galaxy, there's no mass or matter to slow down time or to contract distance. These effects explain superluminal motions up to 20 times the speed of light. Now, I saw a paper one time, they actually published a paper saying that the plasma jet from a galaxy was 7 times the speed of light. And Grok informed me that, well, they have observations up to 20 times the speed of light, which I could have guessed that was the case. So we got the spiral arm dynamics. They're going way too fast than what they're supposed to be going because of the rate of causation is affected by the speed or the rate of time and a measure of distance. And we have JWST anomalies. So it's like the Earth appearing flat locally, but on a much larger scale, it's round. So from our perspective on the Earth, time and distance don't change much. But on a larger scale, it changes dramatically. Just like when we're on Earth, everything looks flat. The Earth looks flat as far as we can see. But on a larger scale, a much larger scale, that flatness is actually round, but appears to us to be flat. Gravitational effects dominate on cosmic scales. Earth's position near the Milky Way's edge supports this model, challenging the standard model's baseless assertions. Okay, so now we're getting into what's observed, which is general relativity. The changing measures of time and distance is actually observed. We've detected dilation of distance or changing measures of distance. That's called gravitational waves. It is very minimum because, of course, it's from an event that happened very, very far away. It's amazing that they can even detect a signal like that. But the standard cosmological model assumes a uniform flat space-time manifold and constant light travel metrics, grounded in assertions like the cosmological principle and Hubble constant-based estimates, without empirical validation in regions of minimal mass, in areas where there's no matter between galaxies. These assumptions led to overestimating distances. The 26,000 light years to Sagittarius A, which, by the way, is not really that far away from 6,000 years. and an inflated universe 13.8 billion years. So we propose that the space-time exists only with matter and mass and gravity. So without matter, mass, and gravity, such as the Milky Way or black hole, Earth or Sun, that there is nothing to slow down time or to contract distance. So that means time is instantaneous and distance is infinite. Okay, it's only matter, mass, and gravity that change, that slows down time and contracts distance, making our physical existence possible. Because without that, our physical existence would be impossible. In interstellar and galactic voids, time accelerates and distances expand, allowing light from local and distant sources to reach Earth in under 6,000 to 7,000 years of proper time, driven by differential causation rates, physical processes per unit time, like Earth appearing flat locally, but round on a larger scale. Somebody says globally. Gravitational effects are profound on cosmic scales. So the Earth's position in the Milky Way's edge amplifies these effects, explaining superluminal motions 20C, spiral arm dynamics, JWST, redshift anomalies, and a younger universe, refuting the standard model's unfounded assumptions, trying to make this as clear as possible, walking through it step by step. Okay, the theoretical framework, challenging standard model assumptions. Standard model's reliance on a uniform flat space-time, even in massless voids, lacks evidence. The cosmological principle asserting homogeneity and isotropy and a Hubble constant based distances metric assumes a constant space-time properties without testing gravitational variations. These assertions ignore the dynamic interplay of mass and space-time, leading to erroneous distance age estimates. So in the void of space-time, in voids with negligible mass, space-time exhibits accelerated time. Okay. And that's accelerated time right there. And expanded distances with intergalactic voids showing greater effects than interstellar voids. Okay. So between galaxies, the effect of the lack of gravity is much greater than inside of a galaxy. Okay, the line element is this, but with extreme temporal acceleration and spatial expansion, rejecting flat space-time assumptions. It's called the Minkowski flat space-time assumption. Okay, so he thinks it's all constant between here and there, which cannot possibly be. Within the Milky Way, a radical gravitational gradient applies. Okay, near the center of the Schwarzschild metric induces time dilation. outside the solar system, gravity decreases approaching interstellar void conditions. Okay, the light propagation model for light from Sagittarius A, 26,000 light years, and distant galaxies, Earth's position yields the proper time in voids, distances scaled by K for Sagittarius A with 50. This is going through the math, which I knew could be done. It's just that I didn't know how to do it, because I could see the result of general relativity. If it's true that time speeds up away from gravity, the gravitational well, and if it's true that distance expands, then it's also true that between galaxies there's nothing to slow down time or contract distance. So for a galaxy with 80 galactic segments, add minor time dilation, keeping total 7,000 years. So the math is right there. Of course, if you know the math, you can understand it. I could understand it in my head, but I couldn't write it down. Cosmological implications. The standard model's baseless assumptions inflate distances and light travel times. Because, of course, when you change the measure of speed of anything, you're changing the speed. You change how fast the clock is moving, you're going to change the measure of speed. If you change the distance, you're going to change the measured speed. JWST's redshift galaxies appear closer. No, they are closer. Now he always says it appears closer. Well, it appears closer because it is closer than what the measured distance or calculated distance is. So, in other words, the redshifted galaxies, because of this 13.8 billion years, this is the same distance as from here to the black hole. And that's why you can get 7,000 years in both directions, because we can detect redshifted galaxies and we can detect redshifted light around the black hole. Beyond that, we can't detect it. Beyond the most distant galaxies, we can't detect them. So we're looking at basically the exact same distance between us and the black hole of where we can see, and the most distant galaxies that we can detect. It's about the same distance, but it appears like the black hole in the center of the Milky Way is closer to us. And it appears like the most distant galaxies farther away from us, but actually it's just as close as the center of our own Milky Way galaxy, because of the changes of measures of time and distance, and the rate of causation, because the closer you get to a black hole, the slower the rate of causation is going to be. The slower things appear to us to be, because they are slower by our measure of time and distance. And things are faster when you look outside of our galaxies. The spiral arms are faster by our measures of time and distance. Superluminal motion, the plasma jets shooting out from a galaxy, do exceed the speed of light by 20 times by our measures of distance. But since you can't break the speed of light, it's not going 20 times the speed of light. It's actually going less than the speed of light. But by our measurements, it appears to be going 20 times the speed of light, but it's not, obviously. So the conclusion. Rejecting the standard model's unverified assertion of uniform spacetime and constant metrics, we propose that voids lacking mass exhibit accelerated time and expanded distances, allowing light from Sagittarius A and distant galaxies to reach Earth in under 6,000 to 7,000 years. These effects explain superluminal motions, spiral arm dynamics, and JWST anomalies. The Earth analogy being flat locally and round on a much larger scale highlights the scale-dependent gravity. Earth's position supports a universe age under 7,000 years, demanding a reevaluation of cosmological models, grounding it in observations rather than assumptions. So there we have it. So it's really not that complicated. Of course, the math is a little bit complicated, but if you do the thought experiment in your mind, it's easily understood. And I always suspected that I would be able to show that the 13.8 billion years by our measurement is not the actual distance. The 13.8 billion light years is not the actual distance. At least it appears to be that distance, but it's not really, because it's the same distance from the farthest redshifted galaxies, the same exact distance as between us and the center of our own Milky Way galaxy. Just that the distances are compacted and contracted inside of the galaxy, and outside of the galaxy, they're expanded and stretched. And time passes by much faster where there's no matter mass. So the redshifted galaxies that we're detecting is, of course, from the outer edges of the galaxies. So which is already almost in the void of space. So between there and here, which were on the edges of our galaxy, it's all dominated by the lack of gravity, by the void of space, as far as time and distance is concerned, which means that the causation rate between here and there is much faster than our measured time. It's really not that complicated. Like I said, the math is complicated, but there it is. But with extreme temporal acceleration and spatial expansion, rejecting the flat space-time assumption, rejecting the flat space-time assumption, because nobody's been out in the void of space to measure it. So how do you know space is flat where there's no matter? And that's assuming. This assumes that without any matter, there would still be this, they call it the space-time manifold. So they're assuming even without any matter at all, there is still going to be this space-time manifold, which they call flat. But how is it possible to contract distance and to slow down time without matter? Tell me that. Tell me that and you win the discussion. there is nothing to slow down time or contract distance without matter and mass. So in the voids with no matter and mass, time is going by much faster and distance is expanded, meaning it's less distant than what our projection is. Okay. So, yep, there you go. It's a whole paper explaining the actual problem. The actual light problem is with the flat space-time. That's an assumption. So cosmology is filled with assumptions, which I listed at the beginning of the video. This is more an observation than an assumption. We're going by observations, what we see and measure in outer space. So there's that. You know, one of the most important videos, you might say, one of the most important videos that anyone will ever see if you're interested in cosmology or things like that. So there we go. Because you cannot trust secular scientists who do not know God, who do not believe in God. You cannot trust their calculations because they're going to make calculations and measurements in line with their ideology. So none of what they say about a black hole, a Big Bang, expansion of the universe, invisible matter, invisible energy, none of that can be trusted. Those are all their assumptions because they reject creation. They don't want a 6,000 year time period. So they put in this flat space-time metric where they're in the void of space where there's no matter to slow down time, and they say it's all constant, and they say with no matter it would still be that manifold there of flat space-time. Well, how is that possible? Tell me, how is that possible without matter and mass to contract distance and to slow down time? So there you have it. It's very, very simple. All you have to do is think through it, and you will see their biases and their assumptions, speculation, conjectures, imagination, and fantasy in order to try to get around the fact of creation. We know creation was a fact because matter can't make itself. Matter can't direct itself or order itself. Energy can't make itself. Energy can't order itself either. Energy can't make itself. Energy can't order itself. So we already know there's a creation. We already know there's a creation. So that means there was a time of creation. And we can, if we look honestly at the facts, we can see when that creation was. So everybody take care, stay close to God, pray always without ceasing, and God will draw near to you. Your truth will enlighten you. You will know your creator of the universe. God bless everybody. Take care.